Hello everyone, I'm Shibangi Mukhopadhyay and today my topic of discussion is pre-formulation studies, and it is a very important chapter of Industrial Pharmacy 1 of B.Pharm syllabus. So in this chapter we want to start it with the definition and the need of the pre-formulation studies. So, pre-formulation studies is defined as the study of the physico-chemical properties of a drug which we have to know before doing any formulation. And if we divide the word pre-formulation, then we can say that pre means prior and formulation means for developing any dosage form. So it is the prior step for the formulation of any dosage form. That is, basically when we do any formulation, before that we have to know that what are the compatibilities of the API with that of the excipients, or whether the excipients we are using are suitable for the formulation or not. And also sometimes we should have to know the chemical properties, that is the solubility, the physical state of the drug, means the API, that in which condition it can be favorable and so on. So it helps to develop the safe, effective and a stable dosage form, and it is an essential part of any drug development process, and it is the characterization and also the evaluation of the physico-chemical properties of a drug substance before performing any formulation and into development of a stable, safe and effective dosage form. And here there are some MCQs regarding the pre-formulation studies and what we have already discussed in the previous slide. So now tell me that what pre-formulation studies involve. Basically, it involves the development of any suitable dosage form for a drug. Next, what is the purpose of any pre-formulation studies? It is to assess the physical and chemical properties of a drug. And what is not a part of the pre-formulation studies? So the formulation development is not a part of the pre-formulation studies because it is basically done before the formulation development. Next, the important part is the principal areas of the pre-formulation studies which we want to cover in this discussion. So it can be divided in several ways, like the bulk characterization, solubility analysis and the stability analysis. So in the bulk characterization portion, we will discuss about the crystallinity and the polymorphism, then hygroscopicity, next fine particle characterization and flow properties. And in the solubility analysis, we should discuss about the pK and Ka concept, next partition coefficient, common ion effect, effect of pH on solubility, thermal effect, dissolution study, solubility enhancement. And the stability studies, the last section, it covers the solid state stability and the liquid state stability. Next, here is a flow chart that how we can divide the pre-formulation studies, like the physicochemical properties. It contains the melting behavior, hygroscopicity, particle size and shape, surface area and wettability. These are the important physicochemical properties which we will discuss further. Next, the bulk characterization. It contains the bulk density, crystallinity, particle size characterization or surface area. Next, powder flow properties and batch-to-batch characterization. Next is solubility analysis, ionization constant, pH solubility, thermal effects, organic solvent dissolution, and stability analysis. Stability in solution, solid state stability, and compatibility. This is a tabular form of the previous slide, which we also discuss further. Now, starting with the bulk characterization, what we can see here, the main part, that is the crystallinity. Crystallinity contains, it contains the crystalline compounds. Crystalline compounds are characterized by repetitious spacing of constituent atoms or molecules. Crystal can be of different shapes, example cubic, tetragonal, orthorhombic, etc. And the crystal habit and the crystal internal structure of a drug can affect the bulk and flow properties as well as chemical stability. So here an important part also, like crystal habit. What is crystal habit? It is an outer appearance of any crystalline and polymorphs which is known as habit. It is the description of the outer appearance of crystal with same or different internal structures. Basically, this habit depends upon conditions of process like degree of saturation, stirring rate, agitation, type of solvent, and presence of any other solvent. And with this habit, the crystalline compounds can also change. Crystallinity has a greater effect on the absorption of drugs. And crystalline compounds may have stoichiometric or non-stoichiometric adduct, but the non-stoichiometric adduct is undesirable and removed. This stoichiometric and non-stoichiometric adduct will be discussed further. Now, one more thing I want to discuss, that crystalline state. About the crystalline state. What is crystalline state? That atoms or molecules which are arranged in a definite manner or which have highly arranged form in a 3D periodicity. This state is known as the crystalline state. And this crystal form has low energy, resulting in low solubility and which show more stability. Based on the physical properties, solids are classified as the cubic, tetragonal, and orthorhombic, which we have discussed before. Next compound is amorphous compound. These are also known as the non-crystalline or freeze-dried liquid form or supercooled liquid, and it has no fixed internal structure like that of the crystalline compounds. Amorphous compounds are those whose atoms or molecules are randomly placed. Some drugs can also exist in amorphous state. They are topically prepared by rapid precipitation and lyophilization. And such drugs represent the highest energy state or higher thermodynamic energy than the crystalline state. As amorphous compounds have less stability, but they have the highest energy level and high solubility. So we can also see that the solubility of amorphous form is greater than its crystalline form. And the structure of amorphous compound also changes with time. Here in this slide, I want to discuss about the differences between the crystalline form and the amorphous form. So, in the crystalline form, we can see that it has a fixed internal structure because it has a 3D form. And the amorphous form, it doesn't contain any fixed internal structure. The crystalline form are in the crystalline form, we can study that the atoms or molecules are arranged in a defined manner, or it has highly arranged in a highly arranged form and arranged with 3D periodicity. And the amorphous form, here we can see that the structural units are arranged randomly in the solid. The crystalline forms are more stable than that of the amorphous form, but the amorphous form are less stable than the crystalline form. And the crystalline form, in case of crystalline form, we can see that it has lesser solubility than that of the amorphous form, but the amorphous form has the highest, greater solubility than that of the crystalline form. The crystalline form are anisotropic in nature, and the amorphous form are isotropic in nature. Crystalline form shows a sharp melting point, and the amorphous form shows a melting range. It doesn't show any sharp melting point or any specific melting point. It shows a melting range. And we also know that the crystalline forms are prepared by the crystallization method, and the amorphous form are prepared by the rapid precipitation method, lyophilization method, or freeze drying method. And here I want to discuss one thing that about the term isotropic and anisotropic. Isotropic term defines that it means the amorphous form has similar physical properties in all directions. Means it shows the similar physical properties in all directions. But in case of crystalline form, it doesn't show the similar physical properties in all directions. And next, crystalline compounds are of also two types, like the simple crystalline compound and the special crystalline compound. And the special crystalline compound is further divided into polymorphs and molecular adducts. So what is polymorphism, and also we will discuss about the term polymorphs. So polymorphism is when a substance exists in more than one crystalline form. The different forms are designated as polymorphs, and the phenomenon is known as polymorphism. Polymorphs are further divided into two types, that is the enantiotropic and monotropic. Polymorphs are single molecule as they contain single type of atom. Its internal structure changes than the original form. Polymorphs have similar chemical properties, but it has different physical properties. For example, melting point, solubility, etc. And the term polymorph, if it is divided, then we can also understand that poly means many and morph means form. And if we can take an example, like diamond and graphite are polymorphs of carbon, but they have different physical properties, but their chemical structure are similar. So in the next video, we will discuss about the molecular adducts, the different types of molecular adducts, and also the different types of polymorphs like the enantiotropic and monotropic. And thank you for your patience.